Hey everyone, welcome to NAB. This is my favorite show of the year. This is sort of like the techiest, nerdiest show I've really ever been to. How many of you, is this your first NAB? No? What about, okay, a couple. What about your second NAB? More than 3? All right, more than 5. So keep your hands up, more than 5. All right, more than 7? More than 10? All right, what number back there? Is your 95th NAB? But yeah, it's a great show. It's sort of something that I look forward to every year. It's really one of the nerdiest shows that we've got. So I'm really a big fan of this show. And it's sort of the only show that I really find where people have the same excitement level as I do about things like cameras and color gamuts. And that's sort of unique to me. I'm in the Burbank facility. We actually just opened, and we're actually building a really sort of advanced facility out there. If you haven't heard about the Burbank facility, we're going to have a full DI suite, camera prep bay. It's a really sort of unique experience that we're building there. So I'm really excited about this show, really excited about Burbank. If you're in the LA Burbank area, I definitely recommend coming and check that out. But today, obviously, we're here for the C700, and that's what I want to talk about. So this is a deep dive into the C700. I say deep dive, but again, we're limited to about a half hour, about 28 minutes to be exact. So we're not going to get as deep as I would like to. Again, I build classes for these cameras that range from the 3 to 6 hour range. So there's a lot to learn about this camera. If you find after this session that you really just are hungry for more information, on the other side of this wall, we're actually doing one-on-one sessions all day. We're doing half-hour one-on-one sessions when I'm not speaking here. I'll be doing catered one-on-one sessions depending on what you want to talk about, whether it's how color gamut transforms into different spaces, or just the C700 menu structure. We'll be doing a lot of really sort of hands-on information back on the other side, the CLL booth. But, obviously we're here for the C700, so let's dive into sort of the 3 main things we're going to talk about today. First, we're going to look at the ergonomics and form factor of this camera. This camera, for those of you who are familiar with the Cinema EOS lineup, it is a very different camera than anything we've ever produced, and a lot of that comes down to ergonomics and form factor. So we're going to spend a lot of time here because I believe it's a really important part of the camera. Then we're going to look at sort of my favorite nerd out parts, the image capture of the camera, how the camera processes the image, what the different shooting modes it can do, really the sort of the meat of the camera. And then we're going to look at a little bit, just briefly, how it integrates into the post-production environments, how this camera can really go pretty much straight into your existing post workflow. So let's first talk about our form factor and ergonomics. I believe that ergonomics is a really underappreciated part of a camera. Ergonomics is how we as humans physically interact with the camera, and that's overlooked a lot of the times. It's really important for operators of all levels to be able to sort of interact with the camera the same way that we interact with everyday items in our life. It's not this like foreign box that we have to sort of clumsily stumble around. It's this really sort of ergonomic camera, and it's been a really sort of big update from our previous Cinema EOS products. So the first deal is our dual side operation. Every other Cinema EOS camera we've had has been designed with a certain mindset. It's been designed for handheld operation, single camera, a single operator. You're doing your focus, you're doing your operation. This is the first camera that is designed for the larger scale traditional production workflow. Operator, first AC, second AC. And the first thing with that is the dual side operation. So we obviously have all of our smart side operation like a traditional camera, but we have all of our primary controls actually doubled up on the dummy side with our remote panel. This panel is called the OU700, very cleverly named. But what this panel does is gives you all the same control on the dummy side as you've got on the smart side. So if you're working in a traditional environment where you've got a first AC, they will really appreciate this panel, which is also where all the media is. Your AC can live on the right side of the camera as opposed to our previous Cinema Series cameras. In addition, that panel is a wired panel. So it is something that's got a little cable on it. That cable can run for 50 plus feet. So this is a really nice panel to put onto like a jib base. So if you're using something like a crane, you can actually mount this panel on the base, control all of your camera features remotely. You're not worrying about wireless transmission. I know if any of you ever worked this show, wireless transmission's a bit of an issue with all this interference. So having a wired option for complete control of the camera is a really, really valuable thing. Another really stark difference is this elongated body. Again, you've all seen, show of hands, how many of you have operated a previous Cinema EOS camera? C300, C100. Most of you probably have. It's why you're here, I imagine, because this is sort of the next evolution of that. This looks like no other body we've ever built. It's elongated. It's much longer. It's got a lot of mounting points on top, on bottom. The most mounting points we ever had on top of a camera was one. A quarter 20, C300 Mark II, C300 Mark I, C100, one mounting point. So the fact that we've got a multitude of mounting points allows us to do things like attach all the GAC we need. My background, I've worked at Canon for about 3 years, but I worked at an accessories company that made all the accessories you would attach essentially to the camera. I love having a cheese plate built onto the camera, having all the bottom mount points for balance, being able to have all those options. Because when we build this stuff up, you guys know, as you start adding wireless video transmitters, as you add LUT boxes, MDRs, you need to have the ability to put those not only on the camera, but in specific places on the camera so that it balances out. So having all those top mounting options is a really, really benefit of sort of that elongated body. But in addition to the idea that we've got this now more broadcast style body, we have a production bundle with the camera that actually comes with a shoulder mount that's got a VCT locking plate on it, so your traditional broadcast style locking plate. And this gets the camera on your shoulder in a balanced manner, much like you would, a certain other manufacturer that makes some of the big broadcast cameras that we've come to use for all the years. But what we're seeing now, and what I'm seeing with a lot of my broadcast clients, is that people are being asked, even in the broadcast world, to shoot with these large format sensors. Everyone wants that cinema look. They all want that shallow depth of field. They all want that beautiful Canon look. And that's what this camera is giving us. It's giving us the Canon look in all the environments we need. Whether you're going to broadcast and you want that beautiful Canon look, or you're going to a Hollywood A camera and it needs to be set up for your first and second assistants. And that is giving that classic Canon look that everyone loves and building it into the ergonomics that everyone needs for different styles of shooting. This is a really big deal for me, integrated power. So this is the first camera we've actually built that doesn't use Canon batteries. So that's sort of a huge jump from previous cameras as well. But what's the biggest deal is that we've always had power input on all of our cameras, batteries or AC inputs. On this camera, we've introduced power outputs. So we have 12-volt and 24-volt power outs, 2 amps. They're the standard area configuration. So the 12-volt terminal is your pin 1 is ground, pin 2 is positive. So you can use any of your standard Alexa cables, any cables you've already built for your Alexa, for your either 12-volt or 24-volt port with this camera, which again helps integrate this camera into a larger production environment. In addition to that, we've also got a Hiroshi broadcast connector on the bottom, so that you can either draw power from that or actually power your servos from your lenses right there on the camera. And then on the back, of course, it comes in a V-mount standard configuration. V-mount plate's got your DTAP battery output on the back, so standard configuration there. But again, the idea that we don't make these batteries. These are third-party batteries. You can get an Anton Bauer battery plate if you want for this. It's, again, building into that larger sort of rental environment, that large production environment. And this is my favorite part. This really comes down to the ergonomics of the camera. Everything else, sort of more form factor, but ergonomics is, again, the idea of how we interact physically with this piece of technology. And Canon has been very good at that all the time. It's something I call Canon tactile. Basically, when you look at this body and we sort of start analyzing the body, you'll see all these weird grooves and plastic nubs, and it's designed there for a very specific reason. Our ND filter, so we can drop in up to 10 stops of ND in front of the sensor. It's a pair of buttons that are mated with this little outline groove right there. If you're feeling along the side of the camera, you feel a pair of buttons indented in a little groove, and you know that's your ND filter. When you go back one row, you've got these little sort of forward slip buttons. You can feel that just by operating the camera and feel that, okay, my finger's sliding forward into a button. I've got my magnifying, my peaking, a little raised plastic nub there, then my false color, my waveform. So I've got all my buttons that I can feel very tactile without actually looking at the side of the camera. Same idea with our control panel. We've got a little plastic nub here, different sized buttons. It's all designed so that we can feel our way around the camera and, as lame as it sounds, be one with the camera. I'm a big proponent of that, really sort of syncing up with the camera and it sort of becoming just an extension of you as you're operating and creating beautiful pictures. Same idea with this remote panel here. These are all slitted from the bottom so you know it's on the top, or from the top so you know it's on the bottom. You can sort of guide your hands towards the buttons. Back here again, another pair of buttons with an indented, a little indented groove there, and then a raised plastic nub, and then all of it is duped up on the remote side operation for your AC. So that's the form factor there. But now let's talk about the real, so the meat of the camera here, our image capture and our sensors. Again, people know Canon for the Canon look, and they've always liked our look. It's just how do we get that into this sort of Hollywood A camera style workflow? And that's where the ergonomics came in. But now let's look at our sort of image here. So sensor technology. I broke this into two sections because we have two different sensors for this camera. We have a rolling shutter and a global shutter, and I'll talk about the global shutter in a minute, but first let's talk about the rolling shutter. So the rolling shutter is our standard sensor. It comes in both PL and EF. What's really nice about the EF mount on the C700 is that it's an EF lock mount, we call it. So basically, it's this hybrid mount. It is an EF mount with all the EF protocol and contacts, but it's got a positive locking mechanism, so it mounts to our lenses much the same way that a PL mount lens would mount. So you don't have to rotate the lens, because obviously if you're putting a big cinema zoom on, that's hard to rotate. If you've got fizz motors on it, you're going to be rotating against the motors. So with this mount, we just, the same way we mount the PL mounts, we just back it up to the mount, tighten the mount, and we've got all the same connectivity of our EF mounts. So it's really nice to have that EF mount with lock on this camera. So the rolling shutter is a 4.5K raster, so it's a 4.5K capture. We'll talk about actually how we can capture that in a moment. 15 stops dynamic range, really fast readouts, and support for DAF. So I want to sort of start looking at this here. So our 4.5K raster, this means two things with the camera. First, it means that if you're shooting to the RAW recorder, the Codex RAW recorder, you can actually capture in 4.5K resolution. So you can physically capture a larger raster size. It is actually slightly larger than Super 35, so you're getting a slightly wider field of view, but you are capturing higher resolution, which helps for if you're going to do motion stabilization in post or just a little bit of panning and scanning. But what I really like it for is this feature. When you're shooting 4K just to the internal cards or even 4K RAW, you get this extra area. Everything outside of this white line in 4K is not being captured. It's a surrounding area. So I can see if my boom operator starts dipping in the frame, or if I'm panning and I see that, oh man, it's a C-stand that I'm about to hit, I can actually see it on my monitor before I see it actually in my recorded area. So everything inside is recorded, and everything on the outside when you're shooting 4K is just there for reference and safety. Now, 15 stops dynamic range, this is a really big deal for this camera. This is a Zyla chart. What this chart does is basically show you how the camera maps every stop of light. This chart goes all the way down to, I believe, 21 stops of light. But we're able to capture 15 stops of light simultaneously with this camera, which makes it really, really good for HDR finalizing in post. So by starting with this huge amount of dynamic range, we're able to really push and pull this footage in post and also make a very, very nice HDR master. For those of you who are a little bit less technical and don't recognize the Zyla charts, I got this little example here that our own Brent Ramsey shot that I've used quite a lot. This is a shot from our original C300, which is a 12-stop dynamic range camera. And basically what Brent did here is actually exposed the spectral highlights, little highlights here of the water, to 80% on a waveform. So in a 12-stop camera, we've exposed 80% these highlights here. But then I want to show you what a 15-stop camera looks like, and you're really going to want to watch the shadows. So here's a 15-stop camera. C300 Mark II is also a 15-stop camera. So it's night and day, but if you watch the waveform, we still don't peak over 80 IRE. There's more is brought up to 80, but we're not peaking over 80 IRE, and we're getting a lot more shadow detail. So practically speaking, we're seeing a huge amount of detail in these 15-stop sensors than we were in our previous 12-stop sensors. That's a really big deal. In addition to that, we've got dual pixel autofocus. Now, I know autofocus is a bit of a dirty word for a lot of the industry professionals, and I don't use it all the time, but when I do use it, it is so helpful. I was shooting a promo for a company, and we did a little slow-mo dolly slider shot on this wine being poured, and I was a single operator. It was just me, because we had to be very small footprints. So I had to pull focus and slider at the same time. But luckily, I actually didn't. I had the dual pixel autofocus. I threw on one of our still lenses, and I was able to track focus as I pushed it on the slider, and it did such a good job. I didn't have to touch the lens at all. So I'm not saying that the dual pixel autofocus is going to replace your focus pullers, but when you're doing these really sort of hard moves in your smaller crew, or if you really got to get that slider move the first time and you can't take marks, that dual pixel autofocus is a huge help. Now, of course, it doesn't work with our Cinema Primes, doesn't work with any manual lenses, so there's still times where you will obviously want a manual lens with the Cinema Prime quality, but I have oftentimes used our still lenses, popped them on there very quickly, and been able to get a really solid autofocus performance out of it. Now, the global shutter, you all familiar with what a global shutter is? Basically, rolling shutter, it scans the image up, down, and global shutter discharges the image all at one time. So you've probably seen rolling shutter artifacts when you pan left and right, a straight bar might actually skew a little bit. Our rolling shutter on the C700 is very fast. It's a very fast readout, so you really don't get much of that distortion, but what you do get is like flicker. So if you're shooting like a car commercial, you've seen probably a lot of times some of the lower budget car commercials on YouTube or car promos on YouTube, the LEDs are flickering on those. That's because of the rolling shutter artifact. When you've got a global shutter, you're getting a full discharge every frame, you don't get those artifacts. So this is a really big deal for car commercials, things where you've got flash photography and you don't want half exposed frames, you want full exposed frames. So the global shutter is a really nice deal, but there are some trade-offs. The global shutter it's a lower resolution sensor. I say lower resolution, 4.3K. It is less dynamic range, 14 stops instead of 15 stops, and there is no autofocus in the sensor because of the nature of the architecture of the sensor. So there are some trade-offs, but it's still a very viable option, and it does only come in PL. The assumption being if you're shooting global shutter, you're probably going to be you want the autofocus, you're probably going to be using the PL mount. But it's very exciting. We actually are showing the global shutter version here for the first time. I had it in our Burbank Center for about 4 hours last Tuesday before NAB, and I did a couple little testing with it. It's a very impressive sensor, and I'm excited. It's, to my knowledge, the first global shutter we've ever made. So I'm very excited about that sensor, and I can't wait to shoot with that a bit more. Now, we've got triple digit GV5 sensors in this camera, processors in this camera. The sensor is always what people talk about, but really, the processors are also a huge deal. It's how we take that information off the sensor and actually interpret it. So what I want to show you, these processors, of course, telling you that there's 3 processors in the camera doesn't really tell you much, but what it does is it allows us to shoot things like we can actually process now either XFAVC or ProRes in the camera, which is nice. Again, if you're integrating this camera into an existing production workflow, having ProRes is a huge deal. Now, I prefer XFAVC for a lot of my work because it is a more efficient codec, arguably. It works at about half the space, but there's visually no difference between the codecs. Really, the benefit of ProRes is integrating it into a larger existing workflow. If it's a ProRes show, this camera can drop right in and work in that ProRes environment. But here is our basically giant data chart telling us all the frame rates, all the resolutions, all the chroma subsampling and bit depth options the camera has. Now, this stuff, people's eyes tend to glaze over with this, so I'm not going to spend too long on this. What I want to talk about instead is actually breaking this stuff down. So a lot of times people will talk about these numbers, and a lot of people actually don't realize what these numbers mean. So I want to just briefly break this down for you and show you what some of these numbers mean in sort of rudimentary introductory terms. So here's our standard, this is our 4K option in the C700, shooting 4K, YCC 422 10 bits. Now, what does all that mean? So I've broken this up into our main sections. We got resolution, our color modeling, chroma subsampling, and bit depth. Now, let's first start with resolution. Resolution is pretty self-explanatory. It's how many lines vertical by how many lines horizontal are we capturing. The C700 captures in 4 primary resolutions internally. So right now we're talking about XFAVC internally. We can capture either 16 by 9, 1920 by 1080, 17 by 9, 2048 by 1080, or we can capture in the 4K resolutions, our Ultra HD 3840 by 2160, or our DCI 4K 4096 by 2160. Now, those are all internal options. I'll talk a little bit later about that 4.5K resolution we've got going to the RAW recorder. But what's really important to note here is unlike some other camera manufacturers, these are all full field of view. When you go from 4K to 2K, we're not doing a center crop at our traditional frame rates. We're actually still processing the full 4K worth of information off the sensor and squeezing it down to 2K or HD. So you're getting the full field of view, and you're actually getting sort of what we call an oversampled version of the image. You're getting a very sharp HD or 2K even when you're shooting in camera. Color modeling, this isn't as important. What's going to be important next is the chroma subsampling option. But basically, have two components, essentially, luma and chroma, your color and your brightness value. In a YCC color sampling, basically the luma and chroma are captured separately so they can be modified independently. You could say strike some of the chroma value, or you could modify some of the chroma value. In an RGB, the luma and chroma are captured simultaneously and they cannot be modified. So if that doesn't make much sense to you, this is where it's really going to pay off. So chroma subsampling, I'm sure you've all heard of 420, 422, 444, and I want to sort of just give you an oversimplified version of what this really means. In 420, so imagine this is a sensor array. We've got all of our pixels here. We've got chroma and luma for each pixel. In a 420 subsampling, scientists said, hey, humans are kind of dumb. They're not going to realize if we sample some of this color, we remove some of this color, as long as we keep the luminance value, human eye won't really perceive that difference. Because I could start turning down the lights here, and you would notice immediately. But if I start changing the Kelvin temperature, it's going to take you a couple seconds, a couple hundred kelvins to notice that color change. So we're just less sensitive to color change than luminance change. So in a 420 sample, this is, again, an oversimplified version of it. But basically what we do is we strike 3 of the 4 chroma values of the sensor, of the readouts, and then we copy over the remaining chroma value and dupe it up. So now here's the original format. Here's what a 420 subsampling compression looks like of it. So imagine we were shooting a green screen, and we've got some brown hair follicles against a green screen. And 420 starts subsampling, and we start replacing some of those green pixels with brown pixels, and it can get kind of messy, and you can get a bad key. So 420 is really not recommended for a post-production workflow. If you're doing any green screening or any sort of color grading, you really wouldn't want to work in 420. It's more of a delivery format, if anything. 422 is the same idea, but we only take away 2 of the chroma values, copy over the remaining 2, and then boom, we get something that's much closer to the original, but still a subsampled option. 422 is sort of the industry standard. It's what our 4K internal is, 422. It is visually indiscernible from our next option, 444, Quad 4. Quad 4 is RGB, so the chroma and luma is unchanged on the sensor. So basically, this is a pure one-to-one sort of reading off the sensor, and this is visually indiscernible to the human eye, but so you might say, why would we ever shoot that? Well, for VFX, because computers are not humans, and computers see things on a pixel level. So if you're doing heavy VFX, heavy color grading, heavy green screening, that quad, or that 444 is going to give you a much cleaner key. It's going to, if you're doing a lot of heavy VFX where you're tracking things with a green screen, it's going to clean things up a lot better. And then lastly, bit depth. This is the most important thing. Imagine, again, oversimplified, you get a little Picasso behind your sensor, and they've got a paint palette, and they're painting each pixel. In an 8-bit encoding, there's only 256 shades of red, green, and blue for a total of 16 million colors, which sounds like a lot, but when we go to 10 bits and we jump up to 1,024 shades of RGB, we go up to 1 billion colors. And then when we go to 12 bits, we go up to 68 billion colors. So a much larger, basically, range of colors to choose from. We get much more smooth gradients, gradient reproduction. Here's an 8-bit image compared to a 10-bit image. So you can see this banding in an 8-bit image is dramatically diminished in a 10-bit image. I believe we're still on 8-bit projectors, so you're still going to see some banding at the limitation of the projector point. And then when we go to 12-bit, you're really not going to see much of a difference because, again, we're not on 12-bit projectors. Just a couple more side-by-sides here. I'm running a little low on time, so I'm going to jump through to anamorphic shooting, Codex RAW integration. So again, we can shoot 4.5K to the Codex RAW, very nice for panning and scanning, up to 100 frames per second. To the Codex RAW, though, we can also capture 120 frames per second in 4K RAW. That is a huge amount of data, but it is a very impressive image. And then additionally, we have anamorphic support. So we have an anamorphic D-squeeze on the monitor out, so you can actually see a proper D-squeeze from the C700. Then lastly, just briefly a little bit of post-production talk. This is sort of my background. The C700, the native MXF files, the ProRes files, that stuff is accepted by all the major NLEs. We have plugins for Avid and Final Cut, and what our plugins allow you to do is actually, it will read some of the additional metadata from the files, so we can see the gamma curve, the color space, and then you can properly apply the LUT you need. So the plugins are very powerful, but you don't need the plugins for DaVinci or Premiere. It will take that stuff in natively. We also have plugin support for our RAW. So Avid can actually see our RAW from the camera, and you don't need to debayer it in our standalone Cinema RAW development software, which is very nice. So you can work in this you need a pretty robust system, but if you're in an Avid, you're probably going to be working on one of the HP systems. But it's a very nice way to be able to sort of integrate that all into one. If you don't have a robust system, the camera actually shoots built-in proxies. We have a whole presentation on this tomorrow, but basically the camera will shoot to an SD card 420, so remember, highly compressed, 8-bit proxies to an SD card simultaneously as we capture either RAW to the codecs or ProRes to the internal CFast card or XFAC to the internal CFast card. And these proxy files have the same time code, the same time code, same file name, same metadata, so it's a really easy workflow to sort of move from proxy to your main source media. So having proxies in camera saves you a huge amount of time, and that's entirely what we're going to talk about tomorrow. The time and therefore money in-camera proxies can save you. And then lastly, just extensive metadata. We can add so much metadata to this camera. You can tag location, you can tag notes. All that metadata can be added via an iPad or a laptop wirelessly. So you can have a script supervisor on set literally adding metadata that is then encoded to the files. Whether it's RAW or XFAC, it will be burned into the files that you can then view in your Avid on your computer with our XF utility. So it's a really, really nice situation for if you're doing a producer, you're a reporter environment, you've got a producer on set saying, okay, we're at the burger joint, doing this. Oh, this is the B-roll, and then all that metadata is searchable. So if you're working in a broadcast environment, you've got thousands of hours of information. You can be doing logging live in the field. So the metadata is something that not a lot of people talk about, but is a really big deal. So I hope you learned something new or maybe learned sort of a new perspective on something. If you want to know more, I will be on the other side of this wall at our CLL booth. We are doing the one-on-ones all day, 30-minute one-on-ones. They're normally an hour and a half, $100 in Burbank, but we're doing them free for 30 minutes here. So if you want to learn more, get a little bit more hands-on, anything from color gamuts to we can take you through taking any of the stuff into the DaVinci or anything like that, come visit me on the other side. And thank you all for listening. Thank you.